Good morning, everyone. Good morning, everyone. I get to make many introductions in my capacity as executive director of Google.org. None has given me as much pleasure as this one. And let me tell you why. First of all, as I look out on the sea of pajamas here, and you think about the world that Jeff lives in, where he speaks at the Security Council and General Assembly and to prime ministers and presidents, you might think this is the first time he spoke to a group this large filled with people in pajamas. But it's absolutely not true. And I know it because I was with him. And it was in August, and he was kind enough to invite me to be his guest as he addressed the Indian Parliament. Now, you may not be aware that the word pajamas is an Indian word, and the clothes that everyone wears in Parliament are, in fact, pajamas. So the last time we were in a session like this, he really was speaking to all the MPs, all the ministers, and they were all wearing pajamas. So he's quite accustomed to this. He's not quite accustomed to the kind of pajamas that Tara is wearing, on the other hand. So Jeff Sachs. Jeff Sachs is an economist. If he is an economist and economics is the dismal science, then he is the poet laureate of that science. I don't think anyone has, in our lifetimes, taken something as horrific as poverty, as unjust, unfair, as the rising gulf between the rich and the poor, and changed people's opinions in a decade from one of hopelessness to hopefulness. His book, The End of Poverty, has been the catalyst for thousands and thousands of young people changing their professions, for governments changing their policies, for NGOs and foundations changing their priorities. I think Jeff has done something that has never been done before in history. I am proud to call him my friend. I'm delighted to introduce you to Jeff Sachs.
Oh my God. It can only be downhill from there. That's unbelievable, Larry. I'm sorry, you need that. That is unbelievable, and it is thrilling to stand before a room full of pajamas indeed. I couldn't fit my robe in the backpack, but delighted to be in this remarkable place with a lot of remarkable people. And I'm also here because three of my favorite people all beckoned simultaneously, and that was Larry Brilliant with the incredible leadership that he's showing, Ed Wilson, who is my guru on saving the planet, because he's been guiding us on how to do that for a lifetime of unprecedented productivity in biology, ecosystems, biodiversity, and the things I want to talk about. And Harold Varmus, who is one of our greatest leaders in health and medical sciences on the planet. And when the three of them call, no matter where you are, I happen to be in Brazil, you come immediately. And with 4 red eyes over 5 nights, I was able to make it here in time. But I would do it any time they call. Any one of the three of them, I have a lifelong promise. Anywhere, anytime, I'll be there. And the chance to talk to all of you at Google is always thrilling. I'm delighted that Google also is in downtown New York, just a few blocks away from where we are at Columbia and at the United Nations. And that's a powerful triangle that we have in Manhattan that I think we can do a lot together to advance the theme of today. It is no joke, the idea of saving the planet. Actually, we have to do it. It's odd that in this unbelievably gorgeous setting and productive setting that we have to think in terms of survival, but we actually do. The world is is both as dynamic and promising as ever in history, and it's also as messed up and dangerous as ever in history. And it's not accidental that the two go together, actually. Our productivity does keep us on the critical edge, it seems. Our productivity has led to changes in the natural and the built environment that are both astounding and deeply troubling at the same time. It's our technology that gives us the capacity to destroy the world and to save the world as well. And you're at the cutting edge of the main technology that can do it, the flow of information and knowledge, which in a democratic world is going to be the only way to get this done. So we're all trying to invent new ways to understand how we live together on a crowded planet, and there's no place doing that more literally than Google. So I'm going to give some ideas and you're going to give some answers. Doesn't have to be today, but it does have to be in our generation. So this is all to get us moving, and especially to get you moving. We are your students, and you have to tell us how to do it. The key to understand this is to understand how completely unprecedented our challenges are from the sweep of human history. It is fair to say everything changed on the planet 200 years ago. We had a breakthrough. Essentially, the breakthrough was mobilizing science in the form of human-built technology, and the core breakthrough was mobilizing energy. And the emblem of the first breakthrough was surely the steam engine and the mobilization of fossil fuels. And fossil fuels really do say it all, because they are the essence of the underlying energy of our age, and they are also a source of the greatest threat to a lot of what we hold most dear and what the planet depends on at the same time. So that's exactly that critical edge. What happened 200 years ago was an explosion of us in species abundance and in per capita economic throughput. So both the number of people on the planet and what each of us does in terms of using Earth's resources went through an unprecedented change. We had never had economic growth before. The concept that economic development or economic growth is an available option was never true throughout human history. There were gradual increases of population. I have to ask Ed whether technically we are weeds, but we do seem to be weeds as a species. We can live in every nook and cranny in global ecosystems. We do spread out to wherever any place on the planet. We are invasive species, pure and simple. And having started from Africa on a journey perhaps 70,000 years ago, we have spread to every nook and cranny. But the species abundance took a qualitative and quantitative change about 250 years ago, and that's because of the breakthrough in capacity to mobilize physical resources and principally energy resources. Energy in every conceivable way, including energy to fix atmospheric nitrogen into the fertilizers that allow us to grow more food than was ever possible technically before the Haber-Bosch process at the beginning of the last century. Well, the population, which had hovered in the low hundreds of millions and gradually crept up to the mid hundreds of millions with little perturbations like the Black Death, which was a minor setback, all of a sudden took off. It looks like no doubt a Google income statement also. If you were to put this on a quarterly basis, just to give you the proper metric, but this is over 2 centuries. And this is a similar kind of dynamic. If you peer back to the national income accounts of the Roman Empire, or the medieval period, or the Renaissance, or the Elizabethan era, or even up through the 18th century, almost no change on the planet, in per capita income. Because per capita income was living at subsistence for 90+% of the planet. there wasn't the margin of fossil fuels, of concentrated solar energy, nicely packaged and stored 200 million years ago, that allowed for the dynamic breakthrough. There wasn't the scientific revolution that allowed humanity to take a persistent step above subsistence. Probably the biggest margin between survival and highest per capita income before the 19th century might have been a 50% margin at the most, but it was very transitory. The number of people that lived above survival levels was negligible. A few monarchs and a few aristocrats, but even the kings and queens of the world barely would survive, and their life expectancy was very short, and they too were subject to the risks of natural hazards, and if famines didn't directly kill them, it brought them down and brought their empires down with regularity. Everything changed economically 200 years ago. So in a bat of an eyelash, we're in a different world. And as Ed Wilson has done more than any other person in the world to remind us, our mental apparatus is built on the African savanna, not in the world of the last 200 years. We have not come equipped to deal with this world or to understand it. And there's something quite fundamental about what's happening, which is that Earth and Earth systems gave us lots of margin on lots of different sides for thousands of years. But with this unprecedented breakthrough that has occurred, which economists champion without necessarily understanding the other side, we've closed the margins within 2 centuries. Again, an amount of time imperceptible from our cultural, political, and mental apparatus. And we don't get it yet. But this actually is the biggest challenge on the planet. The margins have ended. It was said in the 19th century that the closing of the American frontier was a decisive change of American history, because the frontier, which meant we killed a lot of people on our way from the East Coast to the West Coast, was a decisive part of 19th century history. We ended the frontier and we quickly jumped to the Philippines, to Cuba, to war, to a global economic empire, and so forth. That was a change at a national scale. We have closed the global frontier now. That is a decisive change for society, and it's a global change. There's no place to jump. And we have to understand what that implies for us. So roughly speaking, as best we can measure it, and it's very, very crude as you can imagine, human population is an order of magnitude up from the beginning of that inflection. Per capita economic throughput, roughly, although it's almost a meaningless concept, is measured to be an order of magnitude up. So we have 100 times more anthropogenic forcing on the planet, 100 times more human activity weighing on planetary processes than before 1800. And it changes everything: politics, survival, and the whole nature of the economic system. Another Wilsonian concept of central importance is the bottleneck. It's not hopeless by any means. We are passing through a bottleneck right now. And one of the most important reasons for that is actually the good news that the human population is responding to crowding in a lot of ways, and is responding actually to the rise of incomes through a voluntary, unprecedented reduction of human fertility rates. We're in the process of we think, a one-time historic demographic transition from a high mortality, high fertility world before 1800 to a low mortality, low fertility world in the 21st century and onward, if we get this right. But that transition can be a bitch, because in the meantime, the population is going to rise 10 times on the planet. And there's a significant lag, and one of the most interesting and perverse things pointed out in 1798 by Reverend Malthus was that the poor are probably the point where the voluntary fertility rate reduction is the toughest. And so the chance of a demographic trap is greatest in the poorest of the poor places on the planet. Africa is the poorest place on the planet by far. It's also by far the place with the most rapid population growth continuing, because in rural Africa, you still have families having 6 or 7 children, typically, though they can barely survive. And that is 6 or 7 children because they can barely survive. That's the nature of the demographic trap. They're not confident the children will survive, so they have many children. That's the Social Security. They're living on a farm where a 5-year-old can fetch fuel, wood, and water. The costs of childbearing, from the adult point of view, are not so high. The benefits of family chores on a desperately impoverished farm can justify large numbers of children. And so we've got a bottleneck. The good news is that if the UN medium forecast is close to being right, it says that the population peaks in the second half of the 21st century. And the estimate is that in the year 2071, the human population reaches its maximum at 9.1 billion, a mere 2.6 billion people added to what we have right now. Every one of them wanting to live at the levels and with the economic throughput of the rest of the planet. So the proportionate increase is less than in the 20th century and the 19th century. We will almost surely not see another doubling of the human population. But the absolute numbers remain startling. And these increases are going to take place in the poorest of the poor parts of the world. Still, the bottleneck idea is if we can find our way through this difficult continuing transition, we will have an easier time with a stabilized population and with technologies that are already within sight, sometimes already within application at small scale, to enable sustainability in the context of development. Now, let me say a word about what is the fundamental challenge in my view. The fundamental challenge I call sustainable development. Many other people call it sustainability, but I think that's not quite right. Sustainability has the context of ecosystems that function and species that survive. That's clearly a core part of our challenge. But the development side reminds us that we live in a world of profound inequality. We live in a world where the gap between the richest and the poorest is almost definitionally, tautologically, bigger than any time in history. 200 years ago, there was no gap. Everybody was poor. Certain parts of the planet, including where we are today, have soared to unimaginable levels of well-being. Other parts of the world remain almost stuck at subsistence or lower, and many parts of rural Africa are sub-subsistence. That means they are not even at reliable survival levels. Life expectancy may be 35 years because pandemics go unaddressed. Chronic hunger immune suppresses bodies. And so you get life expectancy less than half of the rest of the planet. It's not good enough for us to talk about sustainability. We have to talk about achieving simultaneously sustainability and development, and have to understand fully the weight of the legitimate aspirations of the 5/6 of the planet that would like to live in material well-being, have a future for their children, be part of a world where technology empowers them. And they're going to try to get there no matter what we feel about it anyway. I happen to feel good about that prospect. I just want to say that our challenge is tougher than trying to just put a halt to development or to freeze where we are or merely to sustain. It is to sustain and nurture simultaneously and give a space for development for perhaps 9 billion people on the planet, but in a way that is consistent with the functioning of the Earth's systems. So my favorite expression of this challenge is also summarized by the term that Paul Crutzen has popularized, rightly coined and popularized. Paul Crutzen is one of the three scientists that discovered the atmospheric chemistry of chlorofluorocarbons and the risks to the ozone layer, won the Nobel Prize for that, and said that we are not, as the geologists and the climatologists say, in the Holocene, which is the period since the last glacial. We are in the Anthropocene. We are the first time that Earth systems are dominated by human processes. And this is not a metaphor, this is a literal ecological truth. And it's a startling truth. And it's a degree of closure of that frontier beyond anything that is recognized until you are directed at the evidence for it. One of the people that has led this effort to understand this is Peter Vitousek at Stanford, one of the great ecologists of our time. And what he and colleagues have done is to measure the extent to which humans have come to dominate fundamental Earth systems. And it's absolutely unbelievable, actually, how weedy we are, how invasive we are, and how much we weigh on the Earth systems right now. This graph from a famous paper in Science in 1997 I find very, very helpful as an organizing principle. It tries to measure the extent to which humans actually do dominate various aspects of fundamental Earth system processes. So the first is land transformation. The estimates of Vitousek and colleagues is that humans now appropriate roughly 50% of photosynthetic potential on the planet. This is really important to understand. We take half of the photosynthetic potential for our use. We do that in croplands, in pasture lands, when we pave areas, when we build cities. We can't do another doubling of our land use for photosynthesis, for food supply, for example. It just doesn't exist anymore. And that extent is shocking. Now, what we have systematically done in the Holocene or in the Anthropocene since the Neolithic revolution of agriculture, we have pushed species away because we say that photosynthesis is ours, thank you, not yours. So we don't like predators around, and we don't like other plants around. We want our crops, we want our monoculture, we want our meat diets, and so on. And the loss of biodiversity is not incidental to that, it's the design. Agriculture, by and large, is to create artificial ecologies that push other species away so that we can appropriate the products. And the extent to which this has happened is startling. So when, again, another fundamental concept of Ed Wilson is biogeography and the species-habitat relationship, the scaled laws, the power laws that relate species abundance to habitat range, we have spread out for more grazing land, more farmland, and so forth. And then when we hear that there's massive species extinction, that's not accidental. It's not intentional, but it's not, I should say, it's not incidental. It was the point of being world-scale, high-throughput farmers. That's what farming is about. It's destroying natural ecologies for the sake of appropriation of photosynthetic services. And we've done an enormous amount. We've also invaded major chemical fluxes. Of course, we have taken over the carbon cycle, not in the annual fluxes, but in the change of the persistent concentrations of carbon dioxide in the atmosphere. From the actually for the last 400,000 years, carbon concentrations have been within a narrow range of about 250 to 350 parts per million carbon. We have burst out of a 400,000 year range. We've burst completely out of the Holocene range of the last 11,000 years, which has been at 280 parts per million carbon. We've done that through this most miraculous invention of the steam engine and everything that came afterwards. We would be with life expectancy of 25 years and hoping, praying for adequate rains and dying in large numbers were it not for the steam engine and everything else that came. So as an economist, if I want to remain a card-carrying economist, which I barely am, but still I'm kind of interested in doing it, I actually like development. I want to be clear about that. But the implications of development are really serious, and the scale is shocking. So we have reached 380 parts per million of carbon now. That's the 30% increase of carbon concentration shown in Vitusek's slide. And I'll say a word about that later, but that's the whole climate change challenge. That's not incidental to our age, that is central to our fossil fuel civilization. And fossil fuels are not just a nasty sideshow to our age, they made our society. They made our society. The third is water use. We appropriate runoff to an extent also unimagined. There's essentially no more rivers to dam. Now, dammed rivers are not so bad, I have to tell you, because our lives depend on it. Our quality of life depends on it. It's very easy for us at our multiples of income unimaginable to not like some of these things, but they make our lives. They make our food supply. They make our safety. They store water in drought years. They help us to manage the hydrological cycle. There are many places in the world that do not have reliable water certainly from one season to the next, but really not even safe water from one day to the next, and that have desperate prospects of water stress. This is one of the greatest challenges on the planet. There are no easy solutions right now because there's essentially no easily accessible water runoff to manage. There are still more rivers to dam, but if you dam them, you kill the downstream ecosystems. We are now in a zero-sum world on water. Not that there aren't some better approaches, but in terms of the simple things of water abstraction from underground aquifers and from runoff. And that's why Vitusek shows that water use is 60%. Essentially, it's saying everything that we can grab, we've grabbed already by 2006. Nitrogen fixation, another unbelievably large-scale chemical flux that we have come to dominate. We now fix anthropogenically more nitrogen than the natural nitrogen cycle, which takes N2 and puts it into ammonia, into nitrates, and so on, which are vital forms of active nitrogen that can be taken up by plants and then by animals to build proteins. The essence of the nitrogen cycle is that nitrogen is 78% of the atmosphere. It exists as triple bonded N2. It's one of the most powerful bonds in natural systems, that triple nitrogen bond. It means that organisms, by and large, including us especially, can't take atmospheric nitrogen and use it to build biochemical pathways and proteins. That triple bond has to be broken. That requires a lot of energy and very specialized technology. One kind of energy is lightning, which fixes atmospheric nitrogen into the ground. The other is nitrogen-fixing bacteria, which live symbiotically with plants in nodules, in nitrogen-fixing legumes and other kinds of species. And that's where we get our nitrogen from. And that's why it's so easy also to deplete nitrogen by farming in farming systems where you don't replenish nitrogen by putting fertilizer back in the ground. That's why Africans are hungry and starving now, because they're too poor to use nitrogen-based fertilizer. They've been farming in high-intensity, high-density, fragile tropical soils for a generation now without replenishing nitrogen. And these poor people, we don't tell them the truth, that all of their backbreaking labor every year is for naught because biophysically they are unable to grow a crop no matter how hard they work to weed and to plant and to sow and to tend the soils, because the nitrogen is depleted. And we have been crueler than cruel in saying we'll let markets solve the nitrogen problem. And people are dying by the hundreds of millions. It's one of the, I'm sorry, by the millions, and hungry by the hundreds of millions. And it's one of these false mistakes. Now, I want to talk about the other side of this. On the other hand, we're putting in hundreds of kilograms per hectare of nitrogen into the soils of the rich countries. And we're on the other side of the divide. So much nitrogen is being fixed by our fertilizers now that we're actually doing more than the natural cycle of atmospheric nitrogen being fixed biologically or by lightning and other physical processes. We're doing it now. It's a famous process. It's been called the most important invention of the 20th century in terms of economics, though almost nobody knows about it, the Haber-Bosch process of using fossil fuel to break those triple bonds and make nitrogen-based fertilizers. That's what enabled us to feed 6.5 billion people. But now that nitrogen leads to eutrophication of our water supplies, poisoning of underground aquifers, dead zones off the Gulf of Mexico, massive, massive problems, hardly measured, monitored, managed at all any place in the world. Invasive species, this is plant invasions. The humans are the biggest invasive species, but plant invasions, massive with huge ecological consequences. Extinction of species, this is just one measure. Bird extinctions, I'm going to come back to this in a minute. And marine fisheries, we're overfishing every major fishery on the planet. The point of this is that explosion of people and the explosion of economic activity in a world where we have had vast stores of margin where we didn't understand that there are limits, we've now hit the limits on multiple dimensions. Those limits are going to prove to be highly nonlinear in their effects and highly multifactorial in the impacts. And what I mean by the latter is that we are stressing every ecosystem 5 or 10 different ways right now. It's not just climate change. You think about what's going wrong with the corals, for example, why we may have mass destruction of corals by mid-century. Well, partly it's global warming, rising sea surface temperatures. Partly it's pollution and dead zones. Partly it's invasive species and bilge of ships that are releasing microorganisms and other pathogens. Partly it is overfishing, overharvesting, recreational activity, people breaking up massive corals, destruction of trawlers and many other things. Partly it's acidification of the ocean as the atmospheric carbon dioxide becomes carbonic acid in the sea surface and has reduced the pH by 0.1 already, and that's going to continue. So there are multiple stressors, and it's like fingers in the dike right now. You try to plug a crack here and other cracks there because we are so large in our impact on the Earth's systems, and we understand so few of these systems because so much of this science is new. Ecology, it's been with us for hundreds of years, but I think I'm right, Ed, that the kind of ecology that we need right now is pretty much brand new. And when Paul Crutzen and Sherry Rowland and Molina discovered the hole in the, or discovered the destruction of stratospheric ozone, for example, nobody was even looking for that. That was an accidental discovery, because we didn't have a clue. Chlorofluorocarbons, which could have done us in, were made in the 1930s precisely because they were, quote, inert. They were the safest of safe refrigerants and aerosols for deodorant and everything. And by accident, it was discovered that when they rose to the stratosphere, they had highly destructive effects on the ozone, but it was an accidental discovery. It happened accidentally that NASA had put up a satellite that could actually take a picture of that ozone hole, and we were able to get on top of it. But the point I want to make is, think about that. We were almost fried, all of us, by UV destruction without having a clue as to what was going on. 3 brilliant scientists helped illuminate it. How many other such processes are underway right now, given the unprecedented interference, anthropogenic forcings on the physical systems? Well, you can go in every dimension. This is an attempted ecological reconstruction of where the forests were. Take a look at India, at Western Europe, at the Eastern United States, at Northeast Asia. That's where the forests are now. We're getting down to the tropics. We all talk about tropical deforestation now. That's not because the tropics are special in deforestation. It's because the temperate deforestation occurred for a couple millennia, and the tropical deforestation is catching up right now. This is the Millennium Ecosystem Assessment Report of a couple of years ago. It measures the fraction of potential area already converted from virgin forest or original forest to farmland, pasture, and so forth. And for Mediterranean climate or temperate forest and so forth, there was already 50, 60, 70% conversion. Tropical forests had less conversion until recently because population densities in equatorial zones tended to be lower until the 20th century. Now with rising population densities, we're getting massive deforestation in the tropical zones. That's where a huge amount of biodiversity is, and that's why we're facing this unique extinction crisis, in part by clearing massive amounts of the tropical forest. I was in Brazil a couple of days ago speaking with the Minister of Environment, wonderful woman, Marina Silva, who's battling the destruction of the Amazon. Why is the Amazon under threat right now? Because it really pays to clear the Amazon. Not because people are evil, not because they're wantonly destructive, but because soybeans and meat products carry a high world market price. And China, turns out they like meat too. You know, so as their income levels rise, we're going through an inflection point of a meat-filled Chinese diet. That's only 1.3 billion people. And so they're buying a lot of soybeans because that's a good animal feed. And we're seeing the margin of soybean production now in the marginal areas of the Amazon, meaning increased economic incentive to clear the forest. For a long time, the forest has also been cleared for meat for Europe, for big pasture lands. And so there's an economic forcing, and there's a huge biological threat. She knows it, the Brazilian government knows it, we can do something about it, they're ready to do something about it. I'm going to say in a few minutes some of the things that can be done about it. But this shows what's happened recently. China has become a huge net importer of soybeans in the last decade. This is the clearing of the Amazon. And again, blame is not the right issue here. In my view, morals aren't even the right issue here, frankly. It's understanding processes. It's understanding the connections and understanding the real choices we have. And understanding why we don't want to chop down the rainforest, even though on market terms it makes sense. Now, many people can come for many reasons to similar conclusions, and Ed and I were having a nice discussion a couple of weeks ago at Columbia of whether this is a religious motivation to do something about this, whether it's an economic motivation, whether it's an intrinsic value of nature motivation, and my answer is it's all of those, different things for different folks also. But one thing is clear to me: the underlying processes are poorly understood. And what's happening on the planet is not evil companies doing things. It's not the corporate world that is out to destroy the planet or impoverish the poor and so on. It's basically we're in an unprecedented age of anthropogenic forcings, which we have not come to grips with. And we have not had to care, quote unquote, so much about this, we thought, when there were margins of safety. And we've ended the margins of safety, so we're in a new situation right now. What's the implication? The implication is that we really are starting to push the rest of the species off the planet at an unprecedented pace, because we're so big, so dominant, and interfering in so many systems right now. This is a World Wildlife Fund, UNEP annual publication called the Living Planet Index. It's an attempt to measure species abundance, usually of megafauna. And it shows a significant decline, both of terrestrial and marine species. This is from the Millennium Ecosystem Assessment. It's the argument that we are now roughly at a 1,000-fold increase of species extinction. We saw that another sea mammal was declared extinct a couple of days ago after a major search on the Yangtze River. So this is happening massively now, and the implication that we might reach even a not a 1,000-fold increase, but even a 10,000-fold increase is quite plausible under the combined forcings of climate change, habitat destruction, chemical cycling, and so forth. So we really are saying, this planet's for us, get off to the rest of the species, except for the fact that we don't understand we live in symbiosis with the rest of the species. And so for many, many reasons, this is an enormously destructive path for our own narrow species well-being. But we don't even get all the connections, because how humans interact with the physical environment is a part of ecology perhaps least studied, because ecologists traditionally have put the view on, let's look at the pristine area, not the human impacted area. And I can tell you, the economists don't even look. They literally don't even look. So they don't know what they're doing. And we don't know what it means, GNP, another 1%, how do we do this, how do we do that? I like GNP, again, I want to be clear. But I want it in a context where we understand what we're doing and we're setting boundaries, and we understand the choices and we limit the destructive side. So you find this everywhere. This is a kind of amazing map. This is the fisheries off of Newfoundland. The yellow means that the biomass is estimated at 11 tons per square kilometer at the beginning of the last century. Take a look at what happens to the fisheries off of Newfoundland, off of the Iberian Peninsula, off of France. Watch what happens to the high productivity fisheries. There's nothing left. And that's happening all over the planet right now. There is not a major fishery that is not under assault, because our technology is so damn good. It's been called hunting and gathering with machine guns. Basically, you can clear the ocean. That's hunting and gathering, but now you can put nets that are miles long and or trawlers to scoop up everything on the ocean bottom. And you can destroy entire fisheries. Unimaginable. So this is the total biomass catch of the cod in this fishery. It disappeared, then they closed down the fishery. Doesn't exist anymore as a fishery. These are typical trawlers, and this is what happens when you trawl on a seamount in the open sea, where you have a very complex ecosystem that's never even been explored, cataloged, completely unknown species of incredible biodiversity. Then you drag a damn net over it and you destroy everything. And as Ed says, we're driving the species to extinction before we even meet them, before we even name them. And it's happening on a mass basis. And this year, again, the UN countries, not the UN as a system, but the UN as an arena of negotiation, failed to limit even this open sea wanton destruction of these ecosystems. The amount of fish catch on these deep sea mounts is negligible. And they're trying to market fish we never had in traditional diets. We don't need this fish. But the Spanish and the Portuguese fleets and so forth diplomatically are blocking agreement right now. And this is something where I believe we can make a breakthrough, because this is so stupid when you compare the minuscule benefits of doing this and the huge losses. It's a little bit of a spotlight that's going to break this open. We just haven't done this yet on the fisheries ecologists don't have the voice, they don't have the megaphone to break this open on their own. But I think that this could be ended pretty quickly, because this goes under the title of dumb. Really dumb. Not deep trade-offs, not anguish of societies, just dumb. We should not destroy seamounts for the few fish we catch and irreparably damage critical ecosystems that we haven't even come to know. Climate change is, of course, going to be the biggest, perhaps, of all of the interferences, because every species has its niches, and few species have reliable escape valves. The species are moving north as the isotherms move north, kilometers every decade now because of global warming, so species have to remain within their temperature boundary. If you're an alpine species living on the side of a mountain, you're climbing the mountain range to where you live. There's a limit to that, because you can't jump up from the top. And so we will drive to extinction systematically alpine species. We will drive to extinction systematically polar species, which we're doing, because they have no place to run and no place to hide. And we will drive to extinction species that can't move, or where their prey can't move, or where their communities of symbiotic relationships can't move, or where their habitats block migration. So when you look at what climate change could do even by mid-century, the proportion of species loss is absolutely phenomenal, breathtaking in our capacity to do harm. And we are right now relentlessly on this trajectory. Thank goodness President Bush is worrying about this every day. And his recent series of speeches on, no, not really. Unfortunately, we have not yet arrived at even the basic public discussion of these issues, though the public is way ahead of, actually, I think there are only two areas of deep resistance that remain, and that is the West Wing of the Oval Office and the editorial page of the Wall Street Journal. And the rest of the world kind of knows something's dangerous. What they don't understand is how many potential solutions, again, at very modest cost, there actually are. Because many times when you have these big problems, the biggest problem is too scared to look. That's really fear and ignorance. Those are the two very closely related deepest problems on all of this. That's why information, in my opinion, is the most powerful solvent for real solutions. It's basically fear of confronting this rising curve of global temperatures. This is the map of anomalies that my colleague Jim Hansen has made at the Goddard Institute of Space Studies, 2001 to 2005, compared to the baseline 1951 to 1980. The blue areas, which are not so many, that's where it got colder, and the red areas is where it got warmer. And you see that we are in a warming planet pervasively in all parts of the planet. And it was just announced by NOAA yesterday that we're on the trajectory to be the third warmest year in history for 2006. This is what happens, the nonlinear response of many crucial human crops to temperature increases. Crops have evolved very subtle, complex mechanisms of photosynthesis which are highly temperature regulated. And you go a degree higher and you get disaster. And we're seeing already disasters in many parts of the planet. We had a collapse of the wheat crop because of the drought in Australia, where you have a very good bet that this is an anthropogenic effect. Another example is water stress. That's partly population, that's partly crop needs, because it's crops that take up about 70 to 80% of all water use. Water is a subject that deserves hours of discussion. We mine water like we mine oil. We mine fossil groundwater, or we mine water aquifers that are not fossil water aquifers, but that recharge at tiny fractions of the rate that we're abstracting the water. All over the world, there are water crises brewing by dropping of the water table or depletion of underground aquifers, including the Ogallala Reservoir in the American Midwest, but including, startlingly, the water tables underneath the North China Plain and underneath the Ganges River Basin. So, okay. So let me just finish. I can't stop before saying that crises like Darfur are fundamentally ecological crises that masquerade as political crises. Darfur has not had proper rainfall in 25 years, and that is probably anthropogenic. There is a disaster of drought over 25 years, and there are desperately hungry, impoverished people that cannot water their animals and feed their crops. And that's the origin of the conflict, which started in the mid-1980s. And this, according to my colleagues, is probably anthropogenic, driven by sea surface temperature increases in the Indian Ocean, which systematically lead to declines of precipitation over the Sahel. Malaria, children dying by the millions, also with malaria climbing up mountainsides now, killing adults because they don't have acquired immunity as malaria enters regions where previously it was ecologically not transmitted. What to do? So, can I take 2 minutes? Okay, 2 minutes, sorry. I did not, I like this topic and it requires, unfortunately, better timing than I had. What do we need to do? First, we need to understand what we're doing. And what Google does with Google Earth is unique, and it is world-changing. And if we can systematically harness this kind of spatial information, it is planetary saving. It is a baseline of knowledge which is absolutely essential. It allows for both global scale and local scale understanding of ecosystems, human impacts, natural hazards. BioSearch, which Ed Wilson has conceived, is potentially the kind of breakthrough which will tell us about the biological systems and the human impact interactions. The fact that every village in the world will be online on broadband within the next 5 or 10 years is one of the most positive developments imaginable. We will have the capacity in real time to understand anthropogenic effects and local ecosystem implications everywhere in the world, including with the poorest of the poor. Second point I want to make is that we need a new science. Sustainable development doesn't exist as a department in any single university in the world. The skills that one needs to integrate across ecology, earth systems, environmental engineering, economics, public policy, and public health is a new kind of discipline. I believe it is our 21st century discipline of demand, and it does not exist now, and we need to create it. We're trying to help do that at the Earth Institute. We have launched the first, as far as we know, the first PhD in sustainable development in the United States by insisting on an integrated social, physical science agenda. And it's hard to do, but we're trying to do it. Near-term priorities. Let me very quickly run through this. You just take the hook when it's when you need to. Rainforests. I was in Brazil 2 days ago with the Minister of Environment, with President Lula's top team. They have tabled an important proposal to get global funding to help rainforest countries avoid deforestation. They've tabled it under the framework of the UN Framework Convention on Climate Change. I'm intent on working with the next Secretary General to try to put that into place. This is something that we may want to work on together because there's a great information component to this. It's extremely exciting. All of the rainforest countries are agreed right now. They want to stop deforestation, but they need financial help to do it. Oceans, this is the year when we ought to end bottom trawling. Third, sustainable energy systems. We need to, I won't even go into it. Yes. We need it. Water. Water on a warm, crowded planet. There's a lot to say. Invite me back sometime.
Yes.
It's a more complicated topic than we even realize because we're changing the whole pattern of snow melt, glacial melt, as well as groundwater depletion. It's a profoundly challenging problem, the water problem. Scaling up health services and disease surveillance in low-income settings, like in India with the National Rural Health Mission. And finally, effective globalization, a UN that works. And I just want to say I've been working with the incoming Secretary General as well as with our wonderful current Secretary General. And our new Secretary General, who was inaugurated yesterday, has said that he wants to make sustainable development a centerpiece of his administration and a centerpiece of global leadership. And I want us to help him do that. Thank you very much.
Come on, man.